So we talked about alkanes and how every carbon is sp3 hybridized. If we take away two hydrogens, we can connect the end of the chain and get a cycloalkane. I didn't put it up here, but all of these should have a molecular formula that is C with an N, and then the H would be 2. Let's try that out. 5 carbons, 2N would be, 2 times 5 is 10. 2, 4, 6, 8, and 10. Alkenes have a double bond, and so we're going to go into chapter 3 today, I hope, and we're going to start learning how to name organic compounds. So we have the suffix "ene," which means an sp2 hybridized carbons or double bond, and we'll delineate where the double bond is by a number. And we'll say more about that later, of course. So now we've learned our first functional group. An alkane has no functional groups. Alkanes are relatively inert, but a double bond is kind of reactive. It does certain things. It's electron rich. So we call that a functional group. And then we have alkynes. That's going to have the triple bond. And it has the "-ine" suffix. And once again, the triple bond is a functional group. It has known chemical properties. It reacts in a certain way. So a triple bond is a functional group. A double bond is a functional group. An alkane has no functional groups. So you've probably kind of noticed it by now. The first part of the name tells you how long the chain is, and the suffix tells you about the properties of the chain. Propane, propene, propyne, 3-carbon chain. First had sigma bonds everywhere. Next one had a pi bond. Last one, a triple bond. And then you have to wait for a second semester, and we'll get to aromatic hydrocarbons. For the most part, it's going to be the chemistry of benzene and the like molecules. So here is an alky benzene. I'm going to talk about alky groups, maybe via video to you on Thursday or Friday whenever you check into Moodle. And all the pirates that take my class really like how in OChem we designate alky groups as R. So this R could be an ethyl group, methyl group, some alky group. So oxygen was one of those on the list of elements we find in organic compounds. And a lot of these have their own special chapter. Looking at most of these are going to be second semester. But we're going to get to alcohols in reactions of double bonds. When we react a double bond with water, we're going to form alcohols. What is an alcohol? It's going to have the hydroxy group. And that is a functional group. Ethers. Oxygen forms 2 bonds. So if we connect 2 alky groups with an oxygen in the middle, that's what an ether is. And then aldehydes and ketones have this, what I call a carbonyl carbon, carbon double bonded to oxygen. You're also going to find carbonyl carbon in this carboxylic acid. So this carbon here has a carbon double bonded to it, and then goes out to an OH. So think of that formic acid on the last quiz. You had to do the Lewis structure. So here's our R, which means an alky group. And here's methanol. So meth for 1 carbon. Here's ethanol, F for 2 carbons. Prop for 3 carbons. And then you want to be able to just know all those. Meth, eth, prop, bute, pent, hex, hep, oct, and non. And then dec, unidec, dodec. Then I got up to 12 carbons. So the OH is a functional group, has no chemistry, behaves a certain way. Here's some foreshadowing of great things to come. If you remove a hydrogen from an alkane, you get an alky group, because then you can connect it to something else, like so CH3 bonded to something else is what we call a methyl group. Here's an ethyl group, and a propyl group, and an isopropyl group. And so these are common names for the alcohol using our alky group convention. Up here, this is the IUPAC name. Says meth for one carbon. The A means no double bonds, and the OL means an alcohol. So here's ethanol. It's almost like we had ethane and chopped off the E and added an OL. If I had a 3-carbon chain and there was a hydrogen here, we'd have propane. Chop off the E and add an OL, we have the alcohol, and the 1 designates where on the carbon chain the OH is. I'm kind of old school IUPAC. I like to say 1-propanol. Just rolls off the tongue, where propyl 1-ol just is awkward. If you go to the drugstore and buy isopropyl alcohol, this is what 2-propanol, or propan 2-ol. Nitrogen is a big one in organic compounds. We have amines. Most drugs are amines, like your caffeine, amphetamine, morphine, codeine. They all end in ene. Amides. All those proteins have the amide group. And the nitriles contain a cyano group. Put a hydrogen there, you got hydrogen cyanide, the poisonous gas. Don't have that bond there, you have the cyanide anion, so you can have sodium cyanide, potassium cyanide. So let's learn about the structure and possibly a little bit of stereochemistry of alkanes. As I said earlier, here's this handy-dandy equation. If you know the number of carbons, you can calculate the number of hydrogens when you have an alkane. And we just looked at, if you get rid of this +2, cycloalkane will have 2 less hydrogens because you connected the 2 ends together. These are found in everything from natural gas to petroleum. I would say natural gas is a petroleum product. The smaller the alkanes have very low boiling points, like methane, negative 160 Celsius. Ethane, here's your propane. And in Chem 2, we just got into the intermolecular forces chapter. Why do the larger alkanes have a higher boiling point? The longer the carbon chain, the higher the boiling point. Why is that? Absolutely. Gold star. You're increasing the intermolecular force, more London dispersion forces. All right, so here we can practice counting up to 10 in ochem, methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decane. The CH2 group is called a methylene group, and here's a nice, crazy, fun way to show a homologous series. Might have heard of analogs and homologs. Thought they were the same. I had to study this out. That's not the point of this slide. The point of this slide is, as these things get bigger, the London dispersion force is getting larger. And so here we see a relatively large boiling point for decane. And butane right around 0. So I have a butane backpacking stove, and they used to be horrible. You go camping, it gets below freezing, and they hardly work. But now I got the new kind. You turn the butane can upside down, and liquid flows in, and it's great. And what do you put in your gas tank? When you go to the pump, you get like 89 or 97, or depending on how much money you have. What am I talking about? Regular, mid-grade, premium. Do you read what it says down there on there? The octane rating, those numbers. 85 octane rating, that's some poor gas. 97 octane rating. So it's based on how octane burns. So a lot of hydrocarbons in gasoline. Butane, speaking of butane, here it is. Typically, if I just say butane, I'm thinking N-butane. That means the straight chain hydrocarbon. So how many constitutional isomers does butane have? Talked about constitutional isomers the other day. It has two. There's only two different ways you can connect 4 carbons if they're all sp3 hybridized, and this is it. So we have butane and isobutane. What is a constitutional isomer? Same molecular formula, different order of connection. Now we move up to C5. I always go 5 doubled is 10 and 2 more is 12. C5H12, I know I'm dealing with an alkane. There is only 3 different ways to connect pentane. And when I say pentane, I normally think N-pentane. I don't know what the N stands for. I guess the normal chain. So the N is kind of optional in my mind. I suppose I say the word pentane, you're thinking, well, which one is there? There's 3 of them. So iso, what does iso mean? Well, the pentane, when you see iso and then the name of the hydrocarbon, the pent means 5. 1, 2, 3, 4, 5. Iso typically means second carbon in, you have a methyl group. That's the way I like to think about it. And then here is neopentane. And we still have our 5 carbons, and it's probably the first and last time we're going to use the word neo. So I've been mentioning alky groups for a little while now. I made a video in my office yesterday to put up in lieu of being gone. An alky group is an alkane that has a hydrogen atom removed so that it can be stuck onto something else. So we chop off the AN and add YL to the alkane name. So CH4, we call that methane. If I have CH3 with a little line coming out, so that gets bonded to something, my carbon still has bonds. The 4th item that's bonded to right now is generic. We don't know what. And we call that a methyl group. So we chopped off the ane and put LY, call it methyl. There's a 2-carbon chain. There's where the F comes from, 2 carbons. Ane means they're got all the hydrogens they can take. All sp3. Chop off a hydrogen. There's the hydrogen's gone. Dashed line means it gets bonded to something. All my carbons have 4 bonds. Don't know what this is bonded to yet. So we call that an ethyl group. There's propane. Chop off this hydrogen. There's the 2. Here's this line. It's getting bonded to something else. We call that propyl. 1, 2, 3, 4. 4-carbon chain. Chop a hydrogen off. This is a butyl group. The video you can watch this week. That's going to force me to do it this afternoon. All the other things I'm going to do. We look at all the constitutional isomers of the butyl group. Here is pentane. So pentyl group. We're just going to ignore this for right. Maybe next semester you'll work with isoamyl alcohol. So methyl, ethyl, propyl, isopropyl. If there was an OH here, we'd have isopropyl alcohol. So butyl, I think the 4-carbon chain. Butyl bromide, there's a bromine here. And these would be common names. Now notice we have isobutyl. What's that mean? Butyl means 1, 2, 3, 4 carbons. The second carbon in, we have a methyl group. That's what iso means. Notice up here, propyl. I have 3 carbons. Second carbon in, I have a methyl group. That's what iso means. Well, it might mean isomer. It's an isomer of isobutyl is an isomer. Isobutane is a isomer of butane. That is true, but it helps maybe to visualize this moiety. Of course, it can go down like this. All right, here's 1, 2, 3, 4 carbons long. Second carbon in is where we've chopped off a hydrogen and made this an alky group. So we call this sec-butyl. The sec comes from a secondary. We delineate carbons as primary, secondary, tertiary, and a primary carbon only has 1 carbon bonded to it. So this carbon here we call a primary carbon because it only has 1 carbon bonded to it. This carbon here we call a secondary carbon because it has 2 carbons bonded to it. Now we're all warmed up for this. This carbon has 1, 2, 3 carbons bonded to it, so we call it a tertiary carbon. So here we had the isobutane, and we pull this hydrogen off instead of the one missing there. So this is T-butyl, or tert-butyl. And if I went over that real fast, so how do we name all these carbon chains? I want to be able to name a bunch of alkanes. And we'll see that if we know the IUPAC rules for alkanes, then we're going to go to alcohols and halides, and we keep adding groups. And it's always kind of very similar. First thing is you find LCCC. Now don't drive down to Cheyenne, but it's down there. I'm not talking Laramie Community College. I'm talking longest continuous carbon chain. And I had to change the wording. The book goes a little different, but I like to say find LCCC, longest continuous carbon chain of atoms, and use the name of this chain as the base or the root, that number, meth, eth, pro, oct, non, hex, hep. Number the longest chain beginning with the end of the chain nearest of substituent. What is a substituent? That's something stuck on the chain. That's why you want to learn the alkyl groups, because you might have something that's called 3-methylhexane. That means carbon number 3, there's a methyl group. Give the location of each alkyl group by the number of the main chain carbon to which it is attached. Write the alkyl groups in alphabetical order, regardless of their position on the. So bute normally would come up close. I can't think of an alkyl group that starts with the letter A or C or D. A lot of methyl groups, ethyl groups. Ethyl would be about the next one. So here's a chain, and maybe the first thing I would do is go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. How am I going to choose where I want to start and end? The longest continuous carbon chain, I think I messed up. 1, 2, 3, 4, 5, 6. Turns out, doesn't matter. This is going to be an ethyl substituent here, or if I went this way, 1, 2, 3, I either have an ethyl group here or an ethyl group here. So it doesn't matter. And if I started over here, I'd go 1, 2, 3, and have a ethyl group, or I'd go 1, 2, 3, and I'd have an ethyl group. But I don't want to start over here with the number 1. I start over here with the number 1 because the previous thing, number the longest chain beginning with the end of the chain nearest a substituent. So we start over here because I get a substituent on carbon number 2. If I started over here and went 1, 2, 3, I'd have an ethyl substituent on carbon number 3. So I start numbering the chain right here at number 1. All right, then I see that I have a substituent at carbon number 2 and carbon number 4. Give the location of each alkyl group. That's why we learn the alkyl groups, meth, F, isobutyl, sec-butyl, all those good things, by the number of the main chain carbon atom to which it is attached. Write the alkyl groups in alphabetical order, regardless of their position on the chain. So we do ethyl first, and we say 4-ethyl. Then we say 2-methylhexane. We get the length of the chain. We know they're all single bonds. We know at carbon number 2 there's a methyl group, and we know at carbon number 4 there is a multiple groups. When 2 or more of the same substituents are present, use the prefixes di, tri, tetra, etc. I wonder what all the rest of those are. We'll go over to avoid having to name the alkyl group twice. So once again, the first thing I would probably do is start off going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That way I get to 10. Looks like if I go this way, I'm going to run into my substituent first. 1, 2, 3. This end, I don't get to a substituent until carbon number 4. This end, I get a substituent at carbon number 2, so we want to go this way. So there's a substituent, there's a substituent. I got 3 methyl groups. Here's their positions. This thing's 10 carbons long, so we use decane for 10 carbons long. And then we say trimethyl because there's 3 of them. And so if you have a tri out here, you want 3 numbers. It's tempting if you have 2 methyl groups on the same carbon to only write the 2 once, but you'd want to write it twice. So if this means 3, you better have 3 numbers. If you have tetra out here, you better have 4 numbers. So this is 2,5,7-trimethyl decane. All right, what is an isogroup? Second carbon in, you have a methyl group. So isopropyl, isobutyl, this is isobutane. Chop that off to make it an alkyl group, then you get isobutyl. Should be a 1, 2, 3, 4, 5 carbons. Isopentyl. Second carbon in, you have a methyl group. That's how you want to think about what iso means. All right, so now we get all the numbers up to 10. Di means 2, tri means 3. When you were a kid, you had a tricycle and you got a little better, then you got a dicycle when you went to 2 mils. Tetra means 4. So penta, the rest of these follow our normal counting by organic chemistry. Instead of prop and but and F, we don't have any of that going on. It's di, tri, tetra, and penta. So pentane is 5. Penta would be 5 substituents. Hex means 6. Hexa, this might be where I get tied up at times. Hepta, octa, nona, deca. So I should make another slide where this isn't labeled and we have to figure out what it is. So looking at this, I might just start out 1, 2, 3, 4, 5, 6, 7. Look, I got a 7 carbon chain going that way. 1, 2, 3, 4, 5, 6, 7 going that way. If I just walked in off the street, I might go 1, 2, 3, 4, 5, 6, 7. Why would I want to choose this way? 1, 2, 3, 4, 5, 6, 7. Let me go back. There should be another rule that says number the chains so that if there's more than one way to number the chain, all other things being equal, like right here, I could start here and go 1, 2. It's still come out 2-methyl. But there should be a rule that says give it the most substituents possible. So we're going to have to number this 1, 2, 3, 4, 5, 6, 7. And then I see 3 methyl groups, 1 ethyl group, E before M. So 3 ethyl, 2, 4, 5 trimethyl heptane.